Hello, this is Phil Michaud from PROSTEP. Thank you for joining me, and let's talk about how to exchange data inside and outside your company. So let me start by just giving you an overview of PROSTEP. PROSTEP has been around for about 25 years. We have a good group of consultants that live and breathe this stuff. They not only know your systems, they know our products, and really provide you a match of your data using our systems. And we have over 500 customers that we've implemented our products to. So Siemens is a foundation partner, and we work with Siemens to help you extend your Siemens investment and extend the life of the Siemens products which you've already purchased. We have a large number of partnerships that can help drive and extend your platform based on the Siemens products that you currently own. So if we look at our family of products, we start with our OPENPDM, which is our integration platform. And the next two products, OPENDXM Global X and OPENPDM C Center, which we shortly call Collaboration Center, allows us to extend beyond your four walls of your enterprise to your partners and suppliers. And we can also help you using our foundation OPENPDM to migrate to Teamcenter from other systems in the use of at the point where you might have a merger or an acquisition. We can help you with that and get you to a standard Teamcenter implementation. And we also offer a cross-domain baselining tool called Collaboration Center, which provides a view of your interconnected systems using our OPENPDM platform. If we look at OPENPDM, OPENPDM is the method to be able to normalize your data across your enterprise. It allows you to relate data from your existing repositories and normalize it across all of your repositories. We have OPENDXM Global X, which allows you to extend your IP protection beyond your firewalls when you're dealing with your customers or your partners or other suppliers. You can now secure that data through to them and in return. Of Collaboration Center. And Collaboration Center really is a method to extend your internal workflows out to your partners. Whether your partners have a PLM system or not, it helps them work with you in managing CAD, documentation, bill of materials, and like I said, whether they have a PLM system or not, this can enhance that relationship across your enterprise and help in workflow management. Finally, we got OpenCLM, which is a configuration lifecycle management product, which provides traceability across your interconnected applications. This would sit on top of OPENPDM, and with all of the standardization and normalization of your data, we now can present that in such a fashion to allow you to do baselining, to manage your digital master or digital twin, whatever term you want to use to support your digital thread. It's ultra lightweight and provides relationship mapping across all of your interconnected systems. And it does support your digital thread. So the goal of collaboration is all about getting the right information to the right person at the right time in the right format. And of course, addressing that globally, no matter where your personnel exists in your organization. So the who, the first thing we want to do is understand your organization. Who are your players? What information is important to these players, and at what time is that information required? Plus, also understanding who needs to provide that information to the consumer. So understanding that full vendor-consumer relationship throughout your organization, but looking at it from your personnel's point of view and understanding what your personnel needs in order to be productive and reducing errors across the transmission of this data. The when is really looking at your use cases and understanding what information is needed, when is that information needed, and by understanding that, now looking at your repositories as to where that information is stored and understanding how that information needs to be moved from systems to the right people and providing that information when needed. So, here's a couple examples of some use cases. And this is, not an exhaustive list, but it kind of gives you an idea of what we're talking about, right? So maybe providing your engineering bill of materials to manufacturing and making sure there's a relationship across them, because as you build your digital thread, you're continually looking at the traceability of where that information came from, what information was produced from it, and how does that information interrelate. So understanding the what is important. And I kind of broke this out here as to as expected, as idealized, as designed, as planned, and as built. A lot of people understand and are familiar with an E-bomb. A lot of people understand and are familiar with an M-bomb, right? So engineering bill of materials versus a manufacturing bill of materials. There's also a P-bomb, right? So your production bomb. And your production bomb is very specific and allows you to break this engineering bomb based on the location you're going to manufacture it and understand how that interrelates with your manufacturing location, which now can be translated to your M-bomb during production. So now you can have traceability from what you engineered versus what you're actually building. If you look up a little bit above the E-bomb, you see an I-bomb, and this is I'm kind of coining this phrase. This is your informational bill of materials. This is really the start of your model-based systems engineering, because in the I-bomb is where you start talking about what are my requirements and how does that impact the structure of what I'm going to build? What are the behaviors that I'm expecting out of what I'm building? And what is all the parametric data related to that? So as I can marry that together as I start designing the product, as I start planning to build the product, so prototyping, quality control, things of that nature, where I also have to start looking at my suppliers, providing, the right cost for the right product and making sure quality is met during my prototyping phase. And then getting into manufacturing where I'm now building thousands of these particular items and being able to track what are my serial numbers for each of the pieces of components that I'm putting together. So as now I have this digital thread of my final product and understand how that is married back to what I originally designed in the E-bomb. Understanding the landscape is another what that needs to be paid attention to, right? Because you're going to need to understand the communication channels, and are we within the four walls? Do we have to communicate external? Is there some security that we need to address when I'm communicating across all my applications. And those applications could be within the four walls or outside of the firewall. So how do we do that? I come back to providing a tool that allows the repositories, if you look at the bottom of this, your repositories for your MCAD, your ECAD, your software, your requirements, or each of these could be unique applications. Understanding how those communicate across the individual applications that allow us to place specific connectors for these applications to normalize the data. So as I'm going upward through this slide, right, I'm now normalizing this data where you see PROSTEP's API for the digital thread. And now because I've normalized that data, I now can understand what I'm going to need in order to deliver that data to the right person at the right time. And again, it's all normalized so as the same information only exists once, it's been defined once, the system of record has been defined, and now it's available for consumption. The biggest thing is understanding that we're working under a repository-to-repository communication. The reason for that is we need to get to the data as it resides within these repositories, so as we can identify system of record, we can identify uniqueness, we can identify ownership of that data, and understand how we're going to normalize it. And there are different needs for either replication of that data, federation of that data, maybe consolidating some data at different times. So we need to understand where that data is stored so as we can interact with it across these applications. And this is typically where we're going to see our introduction of these connectors, and it's down at the application base on the repositories. So as this allows us now to have access across your enterprise for your processes, and allows the communications to your personnel and your actors, and understand how that data needs to be provided, when it needs to be provided, and introduce this normalized data. An example of that is an EBOM may require your PLM system for your design and your structure, but all your costing information, your units of measure may be coming from your ERP system, as an example. We can also extend that outside of your firewall, using GlobalX and using Collaboration Center, so as these suppliers can now work just like very seamlessly within your organization and extend that data from their systems to your systems and secure it back and forth. And then why do we want to do this? What we want to do is we want to provide cross-domain integration across all of your applications while we're providing traceability as the product goes through its life, and then providing the productivity that your user community would need to be able to make the right decision based on the right information. So when we bring it all together, think of, here's a simple use case where a project manager needs to know what artifacts in a project at a particular milestone, and where are we with the status of those particular artifacts. Now, what we're doing is marrying the information from an example here from requirements into this baseline. also marrying, the status of where we are in our SysML to this baseline, and also potentially marrying your CAD and your engineering BOM into the same baseline. So now this provides traceability across these particular systems in this example. So do a quick review here, right? So one of the things in managing your data is really to have a plan. And what you want to do is you want to focus on a simplified user experience. You don't want to introduce new windows, new screens. You want to use your existing technology, your existing applications, and make it as simple as possible to introduce interrelated data. The other thing is to identify your strategic data. Where is my system of record for unit of measure? Where is my system of record for part definition, and so on and so on? And then embrace automation. So the whole idea of embracing automation is what can happen, what could we make happen underneath the covers that enhances the user experience without requiring more key access or keystrokes. And then you want to be able to report and audit what you're building, so as now you can refine your processes and always continue continuous improvement. So simplifying your user experience. Use the users the UIs that are currently available to you. If you already have a PLM system and you're already using Team Center, let's not introduce a new UI. Let's use automated services and really look at embedding the processes across your applications for easy deployment and very high adoption. Again, can't stress this enough. Strategic data, you really need to understand your data, and your data may have different life cycles and may change as a program moves from ideation to obsolescence. Example, in the ideation, your requirements are pretty rudimentary, pretty basic potentially at the beginning, because you're kind of defining what you need. You're introducing some SysML, basically, doing some conceptual design. So basically you're still on a napkin. And like I said, you're very early in the process. But as you now introduce detailed designs, now those detailed designs may require you to return and reevaluate your requirements, and may challenge those requirements and requalify or enhance those requirements. Hence, which now qualifies what you've defined in your business models, and your conceptual designs now become much more realistic. So there's a continuous loop potentially until you can move forward to the next step within your phase. So how you do that, there's multitude of ways. We can, with OpenPDM, use an OSLC methodology to introduce those relationships. But as I said, there are multiple ways. Do we need to federate the data? Where does the data need to be presented to the user? And really understand how the data relates to these applications and or process, so as it can be clearly defined and delivered to the right person at the right time using the right set of applications without introducing new software. So the OpenPDM is a seamless product underneath the covers that now enhances all of this, and we enhance it using agents or gateways or robots or RESTful APIs. There's a bunch of different technologies that can be used and those are driven based on the user's requirements. So we need to understand what the user needs, when does the user need it, so as we can identify where that information is and present it at the right time and have it being accurate. So if you put this all together, like I says, as the life cycle of a project moves forward, maybe during your product definition phase, you might have, you've defined your project, you might have some requirements, you're now looking at some modeling and defining some use cases and so on and so forth. So you want to take a baseline, because just before you get into your conceptual phase, you want to understand what it is you had at that time as you're now moving forward in your conceptual phase. So maybe after your detailed design phase, you want to take another snapshot. But now there's more information. There's not only your project management requirements and SysML, but now you have some software that you've engineered because you've done some tests. You might have some mechanical engineering. So is now bringing that all together. Now that might even change some of your requirements. So you might have different variants of your requirements. You might have different variants and enhancements to your SysML. And here you go into pre-production. So let's say you're in the process of now testing and doing some prototyping. You haven't built your tools yet. You want to verify. You're doing some simulation. So now you're going to take a snapshot, and before you do your simulation, and that may introduce some validation, some tools, some expected tool designs. So as you can see, that as your project moves forward through its life cycle of the product, that you're introducing more and more applications, and you're needing to understand, why did I make the decision that I made? And this is what this gives you. This gives you a snapshot of the information you had at the time that you made the decision. And this allows you to now look at future and look in the back and look backwards to be able to understand how you got there until you get that production order and you start building. And again, you can take another snapshot, and so on and so on and so on. So as the idea is to understand, as your project grows, your level of information will grow. And in order to understand the decisions that were made, taking these baselines will provide you that supporting information. And by the way, also marry it to produce maybe your technical data packages, maybe to produce testing samples, maybe to produce manuals, repair manuals, and things of that nature. So there's a bunch of things that could be consumed by understanding what that information is as it was baselined, because that provides you a point in time and the data that existed at that point in time. So if you look at Teamcenter as the hub and look at understanding how Teamcenter can play the role of your master PLM, and understand how you can integrate all of these other systems into Teamcenter, which, by the way, we've done before and we keep doing with our Siemens partner, that we can now provide continuous bidirectional PLM data exchange between your Teamcenter PLM and various other systems that are now interconnected using OpenPDM. And they really extend that outside of your four-walled enterprise also, to include your partners, your suppliers, service providers, customers, and so it all becomes part of your overall solution. We do have other tools available to help you when you're dealing externally. So we can do transparent versioning. We can enhance the communications with blockchain if needed. And we can also deal with additive manufacturing and address additive manufacturing using SAMPL. So with our products, our 3D PDF generator, which also generates HTML5, 3D PDF Pro, which is an enhanced tool that allows you visualization, and then also our integrated product catalog, which now can provide this information in HTML5 for parts catalogs or service manuals. We can now introduce security at that level and limit who can see what and when, and even revoke those accesses if needed. Transparent versions. So let's assume that we had a baseline and we told our quality team to go out and do some testing. So we took a snapshot, we generated a test document for the testing company to go out and do some testing and return some results. While it's sitting in the company that's doing the testing, another revision to the bill of materials may have been created. So we can now send out the newest version and automatically send notice to the recipient that says, hey, there's a new version out there. Please stop using version X and use this new version Y. So this is a very powerful tool that allows even folks external from your enterprise to be current with your latest and greatest. Leveraging blockchain, and this is something that if needed, maybe in the food industry, maybe it's something of interest that you need to be able to track your transactions as it goes external or internal or returns back to your organization. We do have blockchain technology available in our Global X solution that can help you track your information and keep it secure. And then obviously you have the SAMPL, right? Secure Additive Manufacturing Platform that allow you to now introduce 3D printers, and your 3D printers now can become part of your authentication and become part of your secured network. And we can use that to provide guaranteed delivery of the data to your 3D printer, plus also return the information as to a successful print and quality of that print that could be used in a replacement part. So here's a quick example of how SAMPL could be used. So let's assume you have multiple systems that are integrated using OpenPDM, and now you have a customer that needs a replacement part. That customer may go to you and use your integrated parts catalog and find the part that needs to be replaced and confirm, yes, this could be printed using a 3D printer. So we qualify it and we confirm that the particular consumer has the right to print this part, requests that. We can secure that communication back to the printer. And in this case, it might be a third party who's printing this and who owns the physical printer. And we can confirm delivery of that part to be printed. The part is printed, the part is confirmed that it can be used and it passes quality and now can be replaced. But that's not the end of the story, because now you need payment. So now you can actually have payment within that process. So very quickly here you can see how an integrated platform of your data can now be extended to include multitude of other things and enhance the communication with your customers, with your suppliers, and reducing the amount of human intervention required in order to make this successful. So I want to thank you very much. I appreciate you spending some time with me. If you have any questions, feel free to reach out to me. Here's my email. Looking forward to hearing from you. Thank you.